Hello and welcome in, Mark here, aka the Markster. This is video number 17 in the FreeCAD series. Today we're going to take a little bit of a deeper look at the sketcher. I would like to show you all of the elements that are available in the sketcher and all of the constraints that we can use on those elements. Hopefully we'll be able to get to all of those. I just updated FreeCAD a moment ago. Now we're using version 0.19, revision 19.694. So this is the other one was 19.5.10. So 184 commits have been added to the source code between these two most recent revisions that I was using. So I've opened FreeCAD, I've created a new document, I've switched to the Sketcher workbench, and I'm going to create a new sketch. Just open the one that I already created. So we have basically 7 different element types in FreeCAD. We have the point. We have the line, which is a line segment. We have the arc, which is the arc of a circle. We have the circle. By the way, you can right click to get out of the current creation mode. And for the ellipses, we have the ellipse and we have the arc of ellipse. It can be created in different ways. So let's create an ellipse. This constraint, I'll delete it. It was accidentally applied. And the arc. The arc of ellipse. There are different ways to create this object, and you'll get a slightly different number of construction lines and points to manipulate it depending on how you built it. I used this one here on the bottom that time. So that's 1, 2, 3, 4, 5, 6, and we have one more, 7th object, which is a B-spline. With the B-spline, you have 2 different B-splines. One is periodic, and the other is not. The only difference that I can see, a periodic B-spline, if you create it, the last point you add to it a new section will be created linking the last point back to the first. In other words, it'll close itself. The other will not. So you add your control points, and then when you right click, you see it loop back to itself. Right click again or escape key to get out of the B-spline creation mode. The B-spline object is a curve that you can use these control points, drag them around. These are these construction circles. And you can create a large variety of curves. The other B-spline would just be a straight not really straight, curved, but it will not loop back to itself. You see, you have something like this. Delete that one, it was accidentally created. So those are the two types of B-spline objects, but we'll just treat them as the same thing. It's just a B-spline. So 7 basic element types. Each element type can be represented in 3 different modes. One mode is the normal mode, which is visible outside of the sketch editor. Let's close the sketch and we'll view it from the top view. Notice the point is not showing up. The point is always a construction mode object. Notice the control circles do not show up. These are construction mode as well. I double clicked on the sketch to get back into the editor. These construction lines, they do not show up. This point will not show up. Watch when I close. We can go to part and we can actually extrude this sketch in part. It will not make a solid, but it extruded each element. I'm going to undo that. Go back to the sketcher. Create a new sketch. So we're seeing on here the old sketch. We have 2 separate sketches. We can switch to the model view and hide this one if we don't want to see it, if it's going to confuse us or interfere with what we're doing, or we can display it if we want. So we've already seen 2 of the 3 types: the normal mode, the construction mode, and now I will show you the 3rd mode, which will appear as a purple line. That is a link to an external geometry. In other words, some object outside of the sketch, we're linking to it. We use this tool here, create an edge linked to external geometry. So I can link to that B-spline. I can link to that circle, or to this line, or this arc of ellipse, or this ellipse, or this arc. Press the right click to get away from that mode. Close the sketch. Let's hide this one now. Open it back up. So we see our reference mode, I guess we could call it, not to be confused with reference mode constraints. So we have the 3 modes that our objects, our elements can take. You see them listed here. The normal mode, the construction mode, and what I'm going to call reference mode. These are links to external geometry. We close the sketch. None of these links to external geometry show up outside the sketch. They're only used inside the sketch. Just like the construction mode, elements are only used inside the sketch. There are 2 exceptions to that. In the part design workbench, there is a tool is similar to the revolve tool that we've already seen in the part workbench. My voice irritates me. In the part design, there's another tool similar to the revolve tool that you use to do the same thing. It can use a construction line as the axis for the rotation. That is an option in the part design revolve tool. It's the only one I know of. Could be others. The other exception, in the draft workbench, there is a point array tool similar to the array that we worked with earlier in an earlier video. We made the die, we used an array for that. And the wagon wheel, there was another array we used for that. Well, this type of point array, it uses the points that you create in your sketch as locations for the copies of the array object. Only the points, not the points on the ends of line segments and what have you. Just this type of point. So if you needed to have an array of objects at specific areas, you can add a point for each one in your sketch, and then use your sketch as not the base, but to show it's the list of points for the point array. We could go ahead and quickly make one. I clicked here to go into point array point creation mode. Just create a few points. Close the sketch. We go to the draft workbench. Well, let's go to part first and create something that we can use for the base of that array. Now we go to draft. We select our base object first. Control, select the sketch. I believe that's the one I put the points in, hopefully. And we come here and we select this tool, create a copy, selected object on the position of the points. And let's zoom out a bit. So these are all spheres at the locations of those points in the sketch. We see here the base object is a sphere, the point list object is the sketch. I know it's confusing with all these different objects in here. And as we move it, these are parametric. Let me delete that, delete the sphere. Reopen sketch 1. So this is where we have our links to external external geometry from the other sketch. Notice we cannot drag, we cannot move these reference objects. They're there only to be used as references when creating new elements in our sketch. Notice the size and position of this line segment. If I open this sketch, make this one longer and a little bit higher, close it, open this one back up, this remains parametric to that external element. So the use of these objects would be, now we can create elements of regular mode and we can constrain them to those objects. You would not normally create an external link to another sketch. Sometimes you might, but typically it's to some other object. For example, a cube. We might want to center a circle on the face of a cube, so we can cut a hole in the cube, and we could create external links to the four corners of that face, and then constrain our circle to the center using those four corners. You would only need two with a cube. So those are the three modes of the elements can be in: the normal mode, construction mode, and the what I'm going to call reference mode, the purple or magenta, whatever this color is. Let me close this, delete both of these, go back to Sketcher, create a new sketch on the XY plane. Let's add a point. Now we can constrain this point to anywhere we want it on this sketch. We can use these distant constraints. We can use this lock constraint. Let's use the lock constraint first. Click the point, hit lock, and what this does is really just a convenience function. We can do the same thing by using a horizontal and a vertical constraint. It creates one of each for us, is all it does. We could delete them individually or modify them individually. So let's do it individually now. Let's select the object. If I want to constrain it some horizontal distance from the origin, select this horizontal constraint and put whatever value I want, maybe 40. And now it's 40 millimeters away, but it moved. It moved from this side to that side. Did you notice that? So we actually would need a negative 40 to put it where it was. So it's minus direction on the x-axis. And then we could do the vertical. And now our sketch is fully constrained sketch. But is it really? Yes, it's fully constrained. It's the only solution for this object, for this point with these two constraints. There's no other valid solution. It would have to be negative 30 to be in this lower left corner. We can temporarily disable constraints with this tool here. Toggles activate or deactivate state of selected constraint. It becomes gray. And now we can move our object, but it's still subject to that first constraint, the one that is still active. So I put it down here and I select. Sometimes it's difficult to select a constraint in the 3D view. See how much trouble I'm having? You can come here and select in the Constraints panel and make it active again, and you see it moved it back up. Let's delete these two constraints, pressing the delete key on the keyboard. This time I will constrain it to be some distance from here using this fixate length constraint, and we'll put it at 50. So now we can move the point, but you see it's always going to be 50 millimeters from the origin. And now we can apply. We have one more degree of freedom. You see 1 degree of freedom left. Before I added that one, there were 2 degrees of freedom. 2 degrees for each point, an x coordinate and a y coordinate. One way to look at it. If we constrain it using this constraint, now we have 1 degree of freedom. So let's apply a vertical constraint here. We'll put that at 30. So now our sketch is fully constrained. Fully constrained sketch. But is it truly fully constrained? Is this the only unique solution to this, for this very simple model, using these 2 constraints? Is there another constraint? Is there another position for this object that would be equally valid given these 2 constraints? And the answer to that is yes. And the answer to whether this is really fully constrained is no. So let's select that constraint. It is already selected. Disable it temporarily. Now let's move our point over here and re-enable this constraint. So difficult to select in the 3D view. Come down here and select it in the constraints list and re-enable this constraint. Notice it flipped sides. So there were two legitimate solutions for this particular set of constraints. It showed fully constrained in both cases, but there are 2 solutions. This can be problematic when you run into this. Your sketch can end up flipping on you as you're making changes and produce some very unexpected results. So this is not a good way to constrain this point, even though the Sketcher Solver tool agrees that it is. A better tool to use for this would be the angle constraint. The angle constraint will be unique. It will have a unique position for each angle, starting at 0 degrees and going all the way around to 360. We cannot apply an angle constraint to just a point. We need a construction line. So we switch to construction mode, create a line, and we'll create a line connecting these two, connecting the origin to our point. And now we can apply an angle constraint to that point, to that edge, and to the y-axis. We can put it whatever angle we want. Let's say 45 degrees. Now our sketch is fully constrained, and it truly is. There is no other position that would work. There's no other position for this point for which these two constraints would also be a solution. This is a unique solution as far as I know. So it's something to keep in mind as you're constraining your sketches. Angles are preferable in many cases because they provide a unique set of constraints. Let's look at applying some of these other constraints. I believe you already know the coincident constraint. So we can have two line segments. And we select the 2 points that we want to be coincident and use the coincident constraint. And now these two lines are connected at that point. Let me undo that operation. We can use box select, where you start at the upper left, go down to the lower right, and select all of the objects that are completely within the box, in which case it's these two endpoints, and then apply a coincident constraint there. Let me undo that. If we go from the lower right to the upper left to create our box, we get all of the elements that are completely enclosed, or that are partially enclosed in the box. We do not get these two outside points, but we got the edges, because the edges were included partially in the box. If we start at the upper left and go down, we only get the elements that are entirely inside the box. Sometimes 2 points are so close together, it's hard to tell if they are constrained coincidentally or if they're just close. So we can resolve that ambiguity by selecting both and applying that constraint. We have a list of constraints and a list of elements we can use to select the element that we're interested in. But you cannot select the points of an edge, only the edge of a line segment. So that is the coincident constraint. We also have a tangent constraint that will constrain two lines to be tangent to one another. I can highlight these 2 points, press the delete key, and that deletes the constraint rather than 2 points. This point I would delete it because it's a separate point. Press delete, and now all we have left is the construction line. Notice when I deleted those, the constraints went away too. Constraint will never survive deleting the element that it was attached to. You can delete the constraint and the element will remain, but if you delete the element, the constraint will go with it. Sometimes this all turns black. I don't know why. If it's a bug, if it's related to the graphics card that I'm using, or what. But if I zoom in and out, it'll correct that. Or if I close the sketch and open it again, sometimes that fixes it. I don't know why this happens. So now we have a tangent C constraint. These two lines are not only connected with their tangent. It's a very useful constraint with see if I can get that connected, delete it. It's very useful with arcs. Often we want to connect two arcs, an arc to an edge. We have two choices. Well, more than two, but we have the coincident and we have the tangent. Notice the difference here. You can have something like this, which would be good for like if you're making a puzzle, pieces for a puzzle, you might want this. But often what you really want is the tangent constraint. It'll be a very smooth transition from the arc to the edge using the tangent constraint. Sometimes you have it lined up and it looks pretty good, but the tangent is almost always better. We could also connect via delete the wrong thing there. Yeah. I don't think it actually affects using it, this bug or whatever's causing it, but it makes it harder to see what's going on. We can select both of our objects, and there's a tool here. Select the constraints associated with the selected elements. Now I press delete. And I got rid of the end-to-end, the coincident constraint. So I might want to constrain this line segment to this arc here and use the perpendicular constraint. Select the point and the edge, and now this line will always be perpendicular to that edge. Wherever it's located. That's another way to connect. Yet another option. You can use this one. Fix a point onto the edge. So now the point is on the edge of the circle, but it's not constrained to be perpendicular. So those are the ways to connect a point to an edge. Notice it's not on the edge anymore, and yet it's still on the circle. When using this constraint, the point need not be on the edge itself, but it's still constrained to be part of that circle that the arc is part of. Create a new line segment. So we have another tool, another constraint, that is the parallel constraint. Now these two will be parallel. We also have equality constraint. When applied to line segments, this is the equality constraint. They will both be the same length now. So they're constrained to be the same length and parallel. We have the vertical and horizontal constraints. When selected to an edge, the horizontal constraint will force the edge to remain horizontal. And this one, because it is parallel, will also be horizontal. If we apply horizontal to this line, it will probably give us an error. But it did not allow it. See, I have auto remove redundance checked. So it prevented that error without signifying that it was an error. This is a warning I got earlier. If I turn off this and try to apply horizontal, now we see sketch contains redundant constraints. Tells us which one to remove. So it automatically removed the horizontal. That might not be what I wanted. I would have preferred to remove the parallel, depending on what I was doing. So this auto remove redundant constraints can have that negative effect. It's removing what it wants to remove and not what you want to remove. So some advanced users prefer not to have that options enabled. It gives them better control. So we can click to select the recommended constraint to remove and delete it. Sometimes that click to select doesn't work for me. Sometimes you end up down the rabbit hole, so to speak, and you're deleting all kinds of constraints and not seeming to fix the problem. So it's not perfect. You could undo the last constraint when you get a situation like that, and that will remove the last constraint you added. And then you can try to figure out what's going on and how you want to proceed from there. I usually like to do all of my things like equality, parallel, horizontal. Get those types of constraints first, and then the ones that require a number. So I might set both of these lines equal first, and then set one of them to a particular distance that I want. So I can make this line 60 millimeters, and then this one follows with it. So one constraint, 1 degree of freedom we have here would be this radius. Let me set that to 40. Now we have 7 remaining. And that would be the XY coordinate of this point and this point. How long this arc is. I'm not going to fully constrain the sketch, as we're just showing you the different constraints and what they do. Already we're at 40 minutes, so need to wrap this up. The symmetry constraint is one we haven't gotten to yet, so let's look at it. This is where a point can be useful. We can add a point, set this point on the line, and we can make symmetry between the 2 endpoints and the 3rd point. And now when we set this point, we can use this lock constraint to do that. And now we've constrained this line pretty fully. So the symmetry constraint is used between 2 points. Let me kill this sketch and start a new one. This tool here is the rectangle tool. The rectangle is not an element. It's just a tool that creates 4 line segments, 4 lines, and constrains it so that they are 2 vertical and 2 horizontal, and they are all connected with the coincident constraint. So we have 4 coincident constraints and 2 of each of the horizontal and vertical constraints. Often we like to center our sketch. Unless there's a reason not to, you should always center it. When I made the funnel sketch, I did not center because I wanted to rotate about the z-axis, which is the y-axis here, but it was on the xz plane, and I wanted it out over here so I could set the radius with this distance. But ordinarily I would want to center my sketch. Now we can do this by clicking these 2 points in this horizontal axis, creating symmetry between these points. These 2 points are now symmetric to this edge, and we could do the same here. 2 points and an edge, symmetry. And now our rectangle is centered. But that's 2 steps, and it's unnecessary to use 2 different constraints. You can do it all with one, using a point-to-point constraint diagonally. The center point is last. The order of selection is critical here. And now we'll apply point-to-point symmetry. And because the other 2 symmetries that I applied removed the auto-redundant vertical and horizontal constraints, that's why that was messed up. I was just showing you the more inefficient way to do it first. And because auto redundant constraints, auto remove is set, the first symmetry constraint implies verticality between these 2 points, and therefore it removed that constraint. And then now with that one removed, it's not fully symmetric anymore. So when we add horizontal and vertical constraints, let me delete all of these. Those were added to the line segment, but they can also be added to 2 points. So we can select the 2 points and use a vertical constraint on each point. And now these 2 points are aligned vertically. And we could apply it to these 2 horizontal. And now we have symmetry between these 2 and between these 2, but not here. You might want that sometimes in some cases. So keep in mind, you can apply the vertical and horizontal constraints to the points, not just to the line segments. So now we have this symmetry. Easier to apply to the lines, but more flexible applying to the points. And the 2 points need not be on the same edge. You can have another point here, or it could be connected to the end of some object, like an arc or the center of a circle or something. And we can lock this one in using our lock constraint, which just all it does, creates 2 of these with the origin. It's just a convenience, so we can create them both at once. Lock it into place, and now we could create horizontal symmetry, a horizontal constraint to both of those points. And now we're constrained so that this point is horizontal with this point. We have 1 degree of freedom. And that would be the width of this line, or position of this point, or position of this point, or this point on the x-axis, or even an angle could be used with the construction line. So I can just set the length of this line. I could use the horizontal, or I could use the line length. Either one would work. Set it to 200. And now we're fully constrained. The point is always a construction mode object. See, it does not show up. And I think we have 1 more constraint to talk about. Well, we still have the radius, which can be a diameter or a radius, and the angle. And we have this one here, which is a Snell's law constraint. I have to be honest, I don't know exactly how to use that. My understanding, when you stick like a stick in some water or something, it looks like it's a different angle from the part of it that's above the water. That's a refraction effect of the light. So I believe this tool is used to create that angle. It's not something I've ever used or had a need for. I really don't know exactly how to use it. By the way, let me close the sketch. If you go to the help here in the start menu, you can look at your workbench documentation. Shows all the workbenches that I have installed here. We could click Sketcher, and we come down here to all the documentation for all the options. If we look for the constraints, and we see the Snell's law, gives you the information on it. It's all conveniently accessible right here from within FreeCAD. This is how you would use that constraint in a script for a macro or something. So always, as a very last resort, if you can't figure it out, read the manual. For some reason the back is not working. I don't know what's going on there. There it is. The user hub. For some reason that's slow. So these are the different workbenches. If there's one you want to know more about, now here's the part workbench. See, constructive solid geometry workflow. For some reason it's very slow. These links. There we are. So we get the documentation on the primitives. We still haven't covered all of these yet. The shape builder we haven't looked at yet. We haven't looked at ruled surfaces yet. We did briefly look at mirror. We've covered 2D and I think 3D offset. I'm not sure if we've covered that one yet. Projection on the surface is something that we haven't done yet. We haven't made compounds yet, although we have exploded compounds. We've looked at the booleans. The join feature we covered. In case you haven't seen all the videos, these are some of the things that we've covered. Boolean fragments we've used. Exclusive or don't remember if we use that one or not. Defeaturing is something we haven't covered. Section, cross sections. Attachment I think we've used. We've looked at measures. Measuring linear but not angular. So there's still a few things to cover in the part workbench. Once we get it covered fully, we're going to start looking at part design. Probably will still be working in the sketcher. I think the next video I'll make a model using the sketcher and part workbench. Maybe a hybrid model that uses the constructed solid geometry mode method, which is what we first started doing in the series. We began with geometric primitives, and you do Boolean operations on those primitives, combining them in various ways. So that's basically all that is to that. And this uses part design, a more modern workflow, basically sketch based. And we'll get into that in later videos. So we're almost at an hour, and it's gone longer than I'm sure any of you wanted to watch, or many of you will even bother watching. But I think we've covered sketcher, We've covered these constraints pretty well. I still need to talk about this block constraint. Not one I recommend using very often. And we'll talk more about radius and diameter and using the angles a little bit more. We'll also need to talk about these tools here. So we'll talk about all those in later videos. Until then, that's going to be it for now. I thank you for watching and have a great day.